well today. Sorry about the circuit breaker long hair, but hopefully soon that can be cut. Let's talk today about sequences and patterns, which is our mini unit for the last 2 weeks of the year. I'm going to introduce you to a couple of things. Some of them you may have seen before, some of them you may not have done. Obviously, as always, if you've seen it before, feel free to kind of fast forward through, and if not, then please do watch carefully. So obviously you can see the little picture there. We've got an example of a little pattern, and we're going to look at some different things that we can do with this pattern today, and hopefully by the end of it you'll be able to try some of the activities we're going to do in today's lesson. So let's jump straight in. Here is a little pattern. What do we look at in maths for patterns and sequences? Well, we're looking to be able to describe what's going on and also to predict what will happen if we continued this pattern in the future. So being able to describe how we go from one to the next, but also being able to say, oh, what happens if I carried on this for 1,000 patterns? What would that look like? How could we find that out without drawing them all out manually? We're going to come back to this one at the end. So here's an example of a simple pattern. We've got like a triangle that's getting bigger each time. It's like first of all, we can talk about with a sequence where it comes. So that's quite a simple idea. We could say that this here is the first, this here is the second, this is the third, and this is the fourth. So this is the position. So literally, is it the first, the second, the third, the fourth, the 10th, the 1000th? Where does that pattern come? Where does the picture or the number come in the sequence? We could also describe how many or what's going on in each individual thing. So in this first one here, we could see that there are 3 dots. In the second one, there are 6 dots. In the third one, there's 10, and the fourth one, there's 15. When we describe each individual one, we call this a term. Okay, so this here is the third, for example, the third term. A term is just like one part of a sequence. We could say, oh, well, what's going on? How is this pattern continuing each time? So to go from one number to the next, we can look at what's happening. Here we're adding on 3 dots, 4 dots, and 5 dots. So we could say we've got a term-to-term rule. How do you move from one number to the next? And that you could describe that, just to start off with, we could describe it in words. Add on 1 more, great handwriting, each time. So that's like the most basic idea of a pattern. What have you got? And what's happening as you move through the pattern. But we're going to do some slightly more formal things today. So we're going to look at this pattern here in more detail. So first thing we could do is we could again say we've got first, this is the second, third, and fourth. And again, we could say how many dots. We've got 5 in the first one, we've got 8 in the second one, we've got 11 in the third one, and 14 in the fourth one. As you can see here, we're adding on, let me take a highlighter, we're adding these 3 onto this one, then adding another. So our term-to-term rule is that we're adding on 3 extra dots every time. But we need some language that we can use to describe these sequences. So let's just look at the numbers that we've got. We've got 5, 8, 11, and 14. So first thing we could do is we could say, well, we've got the first term, second term, third term, and the fourth term. So here we've got 4 terms. A term is just one part of the sequence, and we can label their position. So this is the position. Well, the term, that's the first. Yeah. Now another way we can describe position is we can give it a value. And we say, instead of saying like first term, second term, third term, we give it a value for n. We say, what is n for this term? N is the position in the sequence. So in this one, it's the second number in the sequence. We say n is 2, n is 3, n is 4. The first one, n is 1. The next number, n, would be 5, and so on and so on. So when you see an n in terms of a sequence, it just means where is it? Is it first, second, third, fourth, and fifth? And it always starts 1, 2, 3, 4, 5, because whenever you're counting, you say first, second, third, fourth, etc. The next thing we can look at is how the sequence is progressing. Now, when we look through this sequence here, we can see that it's always going up by the same amount. It's going up by 3. When it's always the same difference, so when it always changes by the same amount, we can say that this sequence is arithmetic. There are different types of sequences. This one is arithmetic because it's going up by 3 every time. If it went up by 3 every time, or down by 7, or up by a half, whatever it might be, if it's the same every time, it's arithmetic. If it's not the same every time, if it changes, like the sequence we had here, which was going up by a different amount every time, that's not arithmetic. It's only arithmetic when it goes up by the same every time. What do we call this number here? How much it's changing by? We call this the difference. How much is each term? That's not how you write difference. How much each term changes by is the difference. So those are the key terms. Okay, it's an arithmetic sequence. N is where a number comes, and the difference is how much it's going up by. We could then, if we wanted to, we could continue the sequence. Continuing is when you just find the next number. So we could say 14 plus 3, the next number would be 17. We can also go backwards in a sequence. So we could have said, what happens if I went backwards? Instead of adding 3, we'd have to subtract 3, and we'd get 2. But what is this 2? Well, when we look at the positions, it goes up 1, 2, 3, 4, 5. But if we went backwards, we'd actually end up with 0. And if you think about it, that doesn't really make much sense, because if you have a race, you can have the first place, second place, third place. You don't have 0th place. But in maths, this is quite an important number. So in our sequences work, we're going to also see a lot of talk about n equals 0. We're going to talk a lot about position, differences, continuing, but also n equals 0. Now, another thing you can do when you, let's say all of this stuff here, when you get a sequence and you're trying to find out things about it, one little trick I say if you're struggling is to draw this little box around. It looks like a long division sign. And you can label it first, second, third term, fourth, etc. But even better than that, what I would say is you can label it with, write out the actual line, that was terrible. Let's see if I can do really good erasing. You could say, okay, I'm going to say 1, 2, 3, 4, and let's try and find 100 maybe. Let's see if we can do that in a minute. So when you see a sequence, I'd recommend that the first thing you do is you find what n equals 0 would be. So we can see that we're going up by 3, which is the difference, which we sometimes simplify to just the letter d. So d is 3. And we can find n equals 0 by going back, and we can see it's 2. So we can say the difference is 3, and the first term is 2. And we're going to see how we can use that in a second. It's going to jump 2 pages now, because I realise I have 2 of the same. So we've kind of just added that information in. But let's imagine I wanted to find this number here. I want to find n is 100. Well, let's just think about that for a second. Okay? The first term in the sequence is 5, and we're adding on 3 every time. We're adding on 3, and we're adding on 3, and we keep adding on 3 and 3, and we keep going on and on and on. So the first thing you need to think is, how many times have I added on 3? Well, let's think right back to the beginning. Okay? To get this 5, the first number we had to add 3 to something. We had to add 3 to that 2. So 2, we can think of 2 as like the starting term. Let's imagine we start with 2. Yeah? And then you're adding 3. And you're doing that a certain amount of times, depending on where you are in the sequence. The first one we've added it on once. The second one we've added it on twice. And so on and so on. To get all the way to 100, well, we must have added it on 100 times. So I've gone plus 3, plus 3, plus 3, plus 3, plus 3, plus 3, and so on and so on. And that will give us the 100th term. So if we were just going to do it manually, we could just say 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 11, 3 is 11, and so on and so on and so on. But we don't want to do that, we want to do it in a slightly quicker way. So we can start to think about it numerically. Always just think of this here as your starting term, or starting amount, maybe. Okay? It's not literally our starting amount, but if you think of it metaphorically like that, it will help. So, to put it numerically, we did 2 plus 3 100 times to give us n equals 100. So we could say 2 plus 3 100 times is 2 plus 300, which would give us 302. Where do those numbers come from? Oh, no, didn't want to do that slide. Well, 2 was the n equals 0. 3 was the difference. And we multiplied that by what term you're trying to find. And the term we're trying to find is always that letter n. The starting term was 2, the difference was 3, and n depends on the question. Now we've got an algebraic expression. And that algebraic expression, 3n plus 2, it's raining, tells us the formula for the sequence. If I want to find any number in the sequence, I know that I just take whatever n is, where it comes, the position. I multiply it by 3 because I'm adding on 3 that many times. But then I have to add on this starting amount. Let's just check that works. Let's imagine I didn't know this was 11. Okay, let's imagine we didn't know that for a second. But we do know that we're trying to find the third number. So we say, okay, well, I'm going to do add on 3 times. 3 for the n. Maybe I should have chosen a different one, but we'll do 4 in a second as well. I also need to, but I had to start from 2. 3 times 3 is 9, plus 2 is 11, so that one worked. Here we do the same thing. We'd say 3 times something, plus 2, but we're going to add on 3 4 times, because its n is 4. So 3 times 4 is 12, plus 2 is 14, and we can see that there are 14. Let's go right back to the picture. Where does this 3 come from? Well, hopefully we can see, I'm just going to highlight it for you in blue. It's the 3 we're adding, oh, that's terrible highlighting. It's the 3 we're adding on every time. But if you think right back to the beginning, before we had anything, we must have started with these 2 at the top, because they're not part of that triangle, and then we're adding on that little triangle bit at the bottom every time. But without the bits of adding on, We just have those two there. So, we'll come back to the second, but any sequence can be written, the arithmetic sequence, can be written using algebra by looking at the difference and that n equals 0 term. What about if we wanted to work backwards? What about if you were given what we call this here, which I should probably tell you. This here is called an nth term or a formula. Sometimes it's called the general formula. Okay. So we have a sequence, we know it's going to be 3n minus 2, and I want to know what's the first 5 numbers. So I'm going to make the sequence, I'm going to get the numbers like this for this sequence. So what do we need to do? Well, the first thing we do is we know it's going to be the first 5 terms. If you think about counting, you have the first, second, third, fourth, fifth. So we can do the same thing with our sequence. We can say the first number is n is 1. The second number n is 2. The third number n is 3. The fourth number n is 4. And the fifth number n is 5. We also know this 3 tells us we're adding on 3, or 3n is 3 times n. We know that this minus 2 is what we must have started from. So we also know that this n equals 2 here must have been the starting term, that n equals 0. So we know we're going to kind of have negative 2, and then we're going to be adding on 3, this 3 here. Okay. And so on. Or we could say that we're going to do times 3 minus 2. But what are we going to multiply by 3? We're going to multiply n. N is 1 for the first number, 2 for the second, 3 for the third, 4 for the fourth, and 5 for the fifth. So the first one we say n is 1. N is 1. N is 2. N is 3. N is 4. And n is 5. So we do that multiplication. 1 times 3 is 3, minus 2 is 1. 2 times 3 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 4 times 3 is 12, minus 2 is 10. And 5 times 3 is 15, minus 2 is 13. So now I'll highlight it for you. There we go. Now we've got a sequence. 1, 4, 7, 10, 13. We've worked backwards. We can see if we went right backwards, we could have got this number here, would have been the one that came here. And we can see the 3 is because we're going up by 3 each time. And that's what it would look like. So let's go right back to this one that I said we would talk about. We've got grey and black tiles. So what's that going to look like? Well, let's talk about the grey ones first of all. Let's do it in a grey font and I'll make it easy to see. Let's think about those grey those grey tiles, the hexagons. We've got 6 in the first one. And you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the second one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 in the third one. We could then talk about the black tiles. Well, if you look at the black tiles, there's always 1 in each. But we want to know about the total. So how could we find how many there are in total? Let's look at this grey pattern. We can say that the difference, how much it's going up in, is 6 every time. But if we look back to before this 6, we get that n equals 0, which is 0 in this case. So this one is like 6n plus 0. The black ones are nice and easy. They're just 1 every time. That's a 1. 6n here, and we've got a 1 here. So how could we find the 1000th pattern? Well, I've just summarised the information there. The grey is 6n, so we do, well, 6 times 1000. It's going to be 6,000 grey. There's always going to be 1 black, so there's going to be 6,001 tiles altogether. Because we found that using that formula, 6n plus 1, which is 6 times 1000, n plus 1. Okay, so a lot of talking by me, but trust me, when you actually start doing this, it's a lot easier sometimes than making it up. So let's just summarise the things we've talked about. We first of all talked about some keywords. We've got position, n equals 0, and the difference. We also say that each number is a term. So this one here is the second term, term being an important word. We can continue a sequence by just saying, okay, what's changing in this arithmetic sequence? How do I go from one number to the next? We can find a formula by looking at that difference and the n equals 0 and putting them together. And we can generate a number by substituting using our algebra, by taking the formula and putting in those numbers into the sequence. You're going to have a go at this today. I'm going to be around if you need help. And that's a very quick, I've skimmed over quite a lot of things, but hopefully that will get you started today. We've only got 2 weeks on this unit, so I want to make sure that we're covering as much as we can. So obviously we'll start with this, and then any areas that need further explanation, I can make another video to help you with that. So have a go at the activities today, see how you go, and hopefully this will start to make sense the more you practice.